Good day, Algebra 2. It is Friday the 10th, and I am not in today as of the recording of these notes. However, I'm going to go ahead and give you the lesson anyways. So today, we're going back to what we did on Tuesday, and we're going to be solving not inequations, but inequalities of absolute value. Here are some general rules, but these are more like they're like high level written in mathematics language. But I feel like I know you guys well enough to know that usually jumping right into examples is the best way to help you guys understand the lesson of the day. So what I'm going to do is ask that you guys probably should have a separate sheet of paper. These problems don't seem to be quite as long as the ones on Monday. However, depending on how big you write and how legible you write, more specifically, you may or may not be able to fit them all on the screen or on your paper. So if you want to do this on a separate sheet of paper and just write the answers in on the box, that's fine. If you want to fit them all in here, just make sure you write with enough space. So today, we're going to be solving inequalities, and the process is exactly the same as it is with equations, with only one extra step. So what I'm going to do is go ahead and divide these into two columns. And just like on Mondays, I'm going to take what's inside the absolute value bars, because it's already by itself, there's nothing outside of it, and write it exactly the way I see it, less than 2. So x plus 6 less than 2. That's how it looks inside the absolute value bars, and that's how the answer is given, the less than 2 part. Now for the second equation, it's going to be the same thing that's inside the absolute value bars, but to get your second answer, you have to flip the sign and also change the sign of your answer at the end. So these are the two equations I will be solving to get my two answers, because absolute value typically has two answers. So to get the x by itself on both sides, I would subtract 6 from the left, 6 from the right. When I do that, the x falls down. I'm sorry, I have all these extra lines going. This cancels out. The less than symbol falls down. 2 minus 6 is negative 4. So there's one answer. On the right-hand side, I'm going to subtract 6 from both sides, just like I did on the previous problem. The x falls down. These 6's cancel out. The greater than symbol falls down. Negative 2 minus 6 more is negative 8. Now, here's how you have to represent your answer. We're talking about x, and we have two numbers. So I'm going to put one on the left side and one on the right of x. The smallest one goes on the left. The bigger one goes on the right. Now let's see. X is greater than negative 8. So x is greater than negative 8. And over here, x is less than negative 4. So that's the direction my arrows will follow for this one. For these examples, though, the arrows will not always be pointing left like they did with domain and range. Instead, they can be switched in different directions, the same direction, it doesn't matter. So get used to this process that I'm showing you now with the final answer. So x is any number that's greater than negative 8, but less than negative 4. So you can pick a number like negative 5, let's say, which is in that range. Negative 5 plus 6 would give me an answer of positive 1. The absolute value of positive 1 is just 1. And 1 is indeed less than 2, so I know it works. It checks. That's how you check your work. Now for the second example, I'm going to begin the process the same exact way. I'm going to have 4x minus 2 is greater than 10 on the left. And then on the right, I'm going to have 4x minus 2 is less than negative 10 to get that second answer. In order to solve it, on the left side, I'm going to go ahead and add 2 to both sides first, because you have to get rid of your addition subtraction first. 4x falls down, greater than falls down. 10 plus 2 is going to be 12. Divide both sides by 4 to get the x by itself. And then I get x, or 1x, is greater than 12 divided by 4, which is 3. So there's the first part of my answer. Over here, I repeat the process again. I'm going to add 2 to both sides. 4x falls down. The minus 2 plus 2 cancel out. The less than falls down. Negative 10 plus 2 is negative 8. Now I divide both sides by 4. And I get x is less than negative 8 divided by positive 4 is negative 2. So how do I write my final answer? I throw x in the middle. Between negative 2 and 3, negative 2 is smaller. 3 is bigger. And then I know that x is less than negative 2. So x is less than negative 2. Just like the arrow points towards the x here, I have to make the arrow point towards the x here for the negative 2. With the x and the 3 over here, the open part of the arrow, the greater than symbol, is facing the x. So x is greater than 3. So here's an example where the arrows went the opposite direction than what we're used to. So any number that is smaller than -2 or bigger than +3 will work. So a number smaller than -2 would be like -10, for example. 4 times -10 would be -40. Whoops, -40. Minus 2 more would be -42. The absolute value of -42 would be +42, and 42 would be greater than 10. So I know this part works. Now to pick a number bigger than 3. Let's pick +10. 4 times 10 would be 40. 40 minus 2 would be 38. The absolute value of 38 would be 38 still, which is greater than 10. So this one also works. So that's how you check your work there. Now I got 2 more examples to do. Same exact way, and by all means, if you want to go ahead and get ahead of me and then just check your work when I get to it, you can do that too. So I have 3x minus 6 is less than or equal to 15. And then on the right side, I'm going to have 3x minus 6 is greater than or equal to -15. I'm going to go ahead and on the left side over here, add 6 to both sides. I get 3x is less than or equal to 21. Divide everything by 3. And I get x is less than or equal to +7 on the left side. Over here on the right side, I begin the process all over again. 3x falls down, cancel, symbol falls down. -15 plus 6 is -9. Divide everything by 3. And I get x is greater than or equal to -3. So let's write our final answer. We have x in the middle. -3 is smaller, +7 is bigger. X is greater than or equal to -3, but less than or equal to 7. So if you pick a number between -3 and 7 and plug it in for x, it'll make your statement above true, and that's how you can check your work there. So maybe a number like 0, which is greater than -3 and less than 7. 3 times 0 would be 0. 0 minus 6 would be -6. The absolute value of -6 is +6, which is indeed less than 15. So I know that range works. All right, 4th example. See if you can race me if you're getting the hang of it already. X minus 4 is greater than or equal to 7. X minus 4 is less than or equal to -7, excuse me. Sorry, my Siri went off. He's always listening. I'm going to add 4 to both sides of my inequality here. And I get x is greater than or equal to 7 plus 4 is 11. Here, if I add 4 to both sides, x falls down. Less than or equal to falls down. -7 plus 4 is -3. So when I write my final answer, I know -3 is on the left, 11 is on the right because from least to greatest. X is less than or equal to -3. And x is greater than or equal to 11. So I would need a number that's either smaller than or equal to -3, like -5, -6, -7, -8, whatever, or a number on the other side of the number line that's bigger than 11, like or equal to 11, like 11, 12, 13, 14. Anything in those two ranges will make this inequality true. And you can pick any two numbers and check them yourself. Next. Here's the last example. I have x minus 2 is greater than -1. Then I have x minus 2 is less than +1. So if I solve these using my usual algebraic solving methods, I get x is greater than -1 plus 2 is +1. Here, if I add 2 to both sides, I get x is less than 1 plus 2 is 3. So x, I have 1, 3. X is greater than 1, but less than 3. Well, that would be any decimal number that's bigger than 1, so like 1.01, all the way up to 3, so like 2.999, but not including 3. So the whole number 2 actually fits right in there perfectly. 2 minus 2 would be 0. Absolute value of 0 is 0, and 0 is greater than -1, so I know that works, and this is my final answer right here. All right, and our last example for the day. X plus 3 is less than -2, and x plus 3 is greater than +2. I would subtract 3 from both sides on the left over here. I get x is less than negative 2 minus 3 more is negative 5. Here I subtract 3 again on both sides. I get x is greater than 2 minus 3 is negative 1. So I'll write my final answer. Let's see, negative 5 is smaller than negative 1. X is less than negative 5 and greater than negative 1. So you can pick numbers either smaller than negative 5, like negative 6, 7, 8, 9, 10, etc., or numbers bigger than negative 1, like 0, 1, 2, 3, and nothing in between. Anything outside those ranges is good. Anything within there would not work. All right, so that's the basic idea of how you're going to solve inequalities with absolute value. If you have any questions, feel free to email me or wait till Monday when I come back. Or if you really need to know right away, you can talk to Mr. Velasquez next door. He'll be more than happy to answer any questions you might have. All right, I suspect there'll be an assignment attached to this, so look for that. Make sure you have your notes. Keep your notes for your reference, and I will see you guys for the next assignment after this. Have a great weekend, and see you guys when I get back.